So in this slide we will talk about addition formulas of sine and cosine. So we have this figure which we will explain soon. So first notice we have a right angle triangle OPQ. So we just focus on this triangle OPQ. It is right angled. Okay, side OP is of size 1. So hypotenuse in this triangle is OP, which is 1. So OQ is adjacent to angle beta. So you have cos beta there. And PQ is opposite angle beta. So you have sin beta there. Yeah, so let me write this down in the figure. PQ is sin beta and OQ is cos beta. So this is all very simple. This is because triangle OPQ is right angled at Q and OP, the hypotenuse, is of size 1. Okay, now let us go further. So we have another right angle triangle OQA. You have angle alpha there. You also have angle RQO as alpha because RQ and OA are parallel lines and alpha are alternating angles. And then you get 90 minus alpha here as the angle PQR. Yeah, that is because the entire angle OQP is 90 degrees. And therefore we have 90 minus alpha as RQP. And again we have drawn QRP as a right angle triangle. That gives us RPQ as angle alpha. So you should stop here and first figure out all the angles which you have drawn in the triangle. Now we consider this small triangle PRQ. PR and Q. Now PR by PQ is cos alpha because PQ is the hypotenuse of the triangle PRQ and PR is the side adjacent to angle alpha. So by definition of cos alpha, you get side adjacent PR divided by hypotenuse PQ. Now I'm just multiplying by PQ on the both sides, but PQ is sin beta. We have already found that out. So we find that PR is equal to sin beta times cos alpha. Yeah, PQ we have already found as sin beta. So we found cos alpha by working in the triangle PRQ and we just applied the definition of cos alpha, and we know angle RPQ is alpha from before. So similarly AQ by OQ, you work in the triangle OQA. In the triangle OQA, sin alpha is equal to AQ over OQ. AQ is opposite alpha and OQ is the hypotenuse. So I have done nothing. I have now multiplied both sides by OQ, and OQ is cos beta, which is the first equation of this figure. Again I will write OA over OQ is cos alpha. Again we are working in the triangle OQA. A is a right angle triangle and we use definition of cos alpha. Adjacent side OA divided by hypotenuse OQ. You multiply both sides by OQ and OQ is cos beta. So you have OA is cos beta times cos alpha. Now another relation, RQ divided by PQ. So RQ by PQ, we are working again in the triangle PRQ. So this will be sin alpha. Yeah. So now we are in the triangle PRQ. So it is a small triangle. So you have sin alpha here. PQ is the hypotenuse in the triangle PRQ. And RQ is the side opposite to angle alpha. So we just use the definition of sin alpha in the triangle PRQ. Then we just multiply both sides by PQ, and you know PQ is sin beta. We have found that before. This is the second equation we wrote at the top of the slide. So these are all the relations we need to know. Now let us write down the formula. What is sine alpha plus beta? Now we consider the triangle OPB. OPB. In the triangle OPB, sine alpha plus beta is PB divided by OP, but OP is 1, so you just have PB, right? So it is side opposite alpha plus beta divided by hypotenuse, so PB by OP, OP is 1, we just get PB. But PB consists of two parts, PR and RB, which I have just marked in red. Yeah, what is PR? PR is sine beta cos alpha, which I have just ticked. And what is RB? So first let us write this. We have PR and RB is same as AQ. Yeah, you have a rectangle PRQA and all the sides of this rectangle are 90 degrees. So you have PR plus AQ, and I have ticked PR and AQ. So I first write PR and then I write AQ. So this is the formula for sine alpha plus beta. What is cos alpha plus beta? We work in the right angled triangle OBP. So you write OB divided by OP, that is side adjacent to alpha plus beta, over hypotenuse. Hypotenuse is just 1. What is OB? OB is OA minus BA. Now OA we will write as such, BA we will replace by RQ since we have this rectangle BRQA. So this is BA has been replaced by RQ. What is OA? Now OA is this, cos beta cos alpha. And what is RQ? Sin beta sin alpha. Yeah, right here. And so we have found the formula for sin alpha plus beta and cos alpha plus beta just by substituting results in the figure above. Now let us rewrite this formula. Cos alpha plus beta you write as, so I am just rearranging what we already derived. Cos alpha cos beta minus sin alpha sin beta sin of alpha plus beta is sin alpha cos beta plus cos alpha sin beta. So I have done nothing, I have just rearranged what was already written. Now let us apply these formula to certain examples. So first is cos of pi by 2 plus x. So I will just write down the formula. You know cos pi by 2 is 0. So you get minus sin x, because sin pi by 2 is 1 and cos pi by 2 is 0. Again we will just plug in the values in the formula. Sin pi by 2 cos x cos pi by 2 sin x, again cos pi by 2 is 0 and sin pi by 2 is 1, so you get cosine of x. Now we replace beta with minus beta in the formula. So notice that cos of minus beta is cos beta. So cos of minus beta is cos of beta. The only change is caused by sine. Sine of minus beta is minus sine beta. So let us write this down. So the entire change is because sine of minus beta is minus sine beta. And if you write this formula for cos, you will see cos of minus beta is just cos beta. There is no minus coming out because cos is an even function. So cos of minus x is cos of x, and that is why we do not have a negative because of cosine. Again, for sine alpha minus beta, the entire change comes about because of this formula. You replace beta with minus beta in the formula, and because of sine minus beta is equal to minus sine beta, you get a negative sign. Now I will write certain other formulas. Again, we are using addition formulas. So now here you see that sine pi is 0 and cos pi is minus 1. So you get this equal to minus cosine of x, cos pi plus x, yeah, because sine pi is 0 and cos pi is minus 1. Similarly, you write down the formula for sine pi plus x, and you again notice that cos pi is minus 1 and sine pi is 0. And we can again write formulas for cos 2 pi minus x, just expand it and notice that cos 2 pi is 1 and sine 2 pi is 0. And you can again write formula for sine 2 pi minus x.